In this video, I'd like to talk about the math question of the day for January 31st, 2023. And with this problem, we need to find all real valued solutions to the following equation here. This absolute value of x squared plus 2x is equal to 15. And for absolute value equations, especially when we have quadratics, we will need algebra 1 and algebra 2 to solve this. So at this point, go ahead and pause the video, see if you can solve this on your own. And once you've put in a couple minutes of effort at least, go ahead and unpause the video and we can go through this together. Now, assuming that you have attempted the problem, we can work through this together. And as always, if you have any suggestions for future questions of the day, please leave them as a comment below. Now, for this question, since we're dealing with absolute value, it helps to remind ourselves how to deal with absolute value equations. And let's say we have a simple one, absolute value of y is equal to 10. And remember that absolute value is essentially just asking how far is this number from 0 if we had a number line. So there are two solutions to this, -10 and 10, since both of these are exactly 10 units away from 0 here. So these absolute value equations have two solutions usually, though it could be more since we have a square inside this. And when solving these, let me just rewrite it, we would separate this into two different equations and then solve those. The first equation is when this is a positive number and the absolute value bars don't affect it. So we would just have y is equal to 10. But the second equation is when this is a negative value, namely when this is -10 and then the absolute value bar will flip it to +10. Since remember that the absolute value of -10 is simply 10, since -10 is 10 units away from 0. So we would set up our second equation, y is equal to -10. Now, of course, this is simple. We already have the solutions for this. But for more complicated equations, let's say x plus 2 is equal to 11, we would still separate it into two equations. We would have when this is equal to +11 when the absolute value bars don't affect it. So we have x plus 2 is +11. In the other case, when x plus 2 is equal to -11 and the absolute value bars will flip that. So we get our two solutions, and then we can solve for x. We get 9 and -13 here. So we'll follow that strategy for this problem, even though it is a little bit more difficult. So let me scroll over so that we have more room to work on this. And we can scroll down as well. So we will separate this into two equations and then solve each of those equations. We want to look at the case when this is equal to +15. And the absolute value bars won't affect that. And then we'll look at the second scenario when this expression is equal to -15, and then the absolute value bars will flip that and make it +15. Now at this point, we just need to solve each of these equations, but in both cases we have quadratics, so we need to apply the techniques of solving quadratic equations. We will set one side of the equation equal to 0. So let's start with this one. We subtract 15 on each side. So that x squared plus 2x minus 15 is equal to 0. And at this point, we can try to factor it, or we can use the quadratic formula. Though let's try to factor this into a product of two binomials. So each of these will have two terms. We know the first terms in each of these will be x, since x times x is x squared. And we know these constant terms, these numbers, multiply together to give us -15. So we need to think which numbers multiply to -15, and then these numbers will also add to +2. So -15 could be 5 and -3, or -5 and 3, though at this point, we actually already have the values we need. 5 and -3 would add to +2. So this would be +5 and -3. And of course, you can check this by just redistributing and making sure that you get back the original quadratic. And to solve this, we use the zero product property. If either of these factors is equal to 0, then you have 0 times something, which is always 0. So if x is -5 here, then you get 0 multiplied by -8, which of course is 0. And if x is +3 here, then you get 0 times by 8, which again is 0. So these are two solutions. If we plug these in, let's say -5, we get 25 minus 10, which is 15. We plug in 3, we get 9 plus 6, which again is 15. So both of these we can check, they do make sense. Now going to our second equation, we will employ the same strategy. We will set one side of the equation equal to 0. We will add 15 to each side. And with this one, it looks like factoring will not work here, since if we break down 15 into its factor pairs, none of those will add to +2. They will all be greater than that. So for this one, we'll need to use the quadratic formula. And let me write it out generally so that we have it. We have some general quadratic, ax squared plus, let's say b times x plus c is equal to 0. Then x would be the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all divided by twice a. So in our case, we know that a is 1, b is 2, and c is 15. So we get the opposite of b, which is -2, plus or minus the square root of b squared, which is 4, minus 4, times by a, which is 1, times by c, which is 15. So we have 4 minus 60 in there, which is -56. And we're dividing everything by twice a, so this will just be 2. So you get -2 plus or minus the square root of -56 over 2. And the square root of a negative number is an imaginary number. We can manipulate this and essentially pull out the I, so that we get I times root 56 over 2, but this is a complex number. And if we go back to our original problem, notice that we're looking for the real valued solutions to the equation. So even though these complex numbers, these would solve the equation, for this particular problem, we just want real value solutions. So these are not part of our solution set for this problem, so the final answer would just be -5 and 3 for our two solutions.